This is the start of a new series where I'm trying to revise certain topics for the mocks. So the mocks is in a month. So we'll try to push in some videos giving you an overview about some topics which you can work on. I'm not going to go in detail explanation, but give you pointers on how to study or maybe what to study and how to study. Okay. So let's start with number systems here. So the number systems, it's very important that you have an understanding of the number systems because this will be used in most of the questions related to functions and all, because they will tell you what number system to use, and the way you put the values in the functions, it all depends on the number system which is denoted in the question. So I'll just give you a quick recap. So n is a natural numbers, which is a set of all positive whole numbers including zero. Excluding zero. It is denoted by n as such. And the prime numbers, which are numbers which are divisible by that number and only one, and 0 and 1 are not the prime numbers. And then you have z, it is a set of integers. And then you have rational numbers and irrational numbers. Rational numbers are numbers which can be denoted by p over q, and irrational are which cannot be denoted. And real numbers is a combination of rational numbers and irrational numbers. Okay, rational numbers, irrational numbers. And then you have surd notations, which is writing the values in square root forms, root 2, root 3, etc. Root 64 is not as surd because it can be simplified as a value called set. Okay, and here you have to remember the constructions. You have to learn the constructions of root 2 and root 3. Please, if you don't know, please do it now. It's a very easy construction, so go back to your textbook and learn the construction of root 2 and root 3. They can ask the questions at times. Okay, so it's important that you learn it. So these are some of the questions which if you learn, it is a sure mark question. Like if there is a long question, if there is a generic question, you attempt the question, but the chances of getting it correct are less because there can be mistakes and all these things. But these questions, like the proofs or the constructions and all these things, are sure questions. We know that this will come, and if you write that, you will get marks. So these are, like, we can say, low hanging fruits which you can easily grab it. That's why we recommend you to learn it as early as possible. And then there's one more thing which you need to learn here is proof by contradiction of root 2 is irrational. Okay, so contradiction means we just say that, we just assume that the opposite statement is true. That means root 2 is rational. We assume that root 2 is rational, and then do the calculation and then somehow prove that it is not true. Okay, so this is also there in the textbook, so just go back and understand it, memorize it off, learn it off. See, to memorize it, you just try to understand it first, maybe via YouTube video or like looking at the notebook or like notes or things like that, and then try to write it again 2-3 times, and then you should be able to do that and revise it maybe after 1 day or 2 day, so that you won't fall into the like you won't forget the things what you have learned. Okay, and then the last thing here is the order of operations. It is like BEMDAS or BIMDAS, as you have learned, because it is exponents, and in exponent should be done before multiplication, division, etc. So if you have 3 plus 5 to the power of 2, brackets off, so the bracket should be done first, and then the exponents, and then the addition or subtraction, whatever we have in the particular equation. Okay, now we move on to indices. So if I say y is equal to 3 to the power of x, or y is equal to x to the power of 4. So these are called indices. Indices and logarithms will come together, and there are certain laws of indices which are there in the formula book, page 21. So please, whenever you're working on this, open the page 21 and then look at the questions and then do it, so that you don't make any kind of mistakes. Some of the things which you have to remember is like a to the power of 0 is equal to 1. This is all there in the formula book. I'm just explaining it if anyone doesn't know these concepts. So a to the power of minus p is equal to 1 by a to the power of p. A to the power of 1 by q is equal to qth root of a, and there are so many other things. Okay, so with this there will be problems, and they will not ask you direct questions from this, but you have to apply this in certain other questions. For example, if there is a question like 4 times 2 to the power of x plus 1 is equal to 64, and this is for solving means finding the value of x. So what you can do is like 4 to the power of 2x plus 1 is equal to 4 to the power of 3, then 2x plus 1 is equal to 3, and x is equal to 3 minus 1 2, and that is equal to 1. Okay, so this is how you can solve the equation. Again, same things, just to go into a bit detail on this. So 3 to the power of 3x minus 1 is equal to 9 over root 3 to the power of 2. So 3 to the power of 3x minus 1 is equal to 9 can be written as 3 square over root 3 can be written as 3 to the power of 1 over 2 to the power of 2. And as we know, you have to simplify the brackets first, Bemda's rule. So it is like 3 to the power of 2 minus 1 over 2 to the power of 2, which is equal to 3 to the power of 2 into 2 4, 4 minus 1, 3 over 2 to the power of 2, which is equal to 3 to the power of 3. Okay, now equating it to the left hand side, 3 to the power of 3x minus 1 is equal to 3 to the power of 3, and 3x minus 1 is equal to 3, 3x is equal to 3 plus 1 4, and x is equal to 4 over 3. Okay, so this is how you do it. And now if you get a question like 5 to the power of 2x plus 1 minus 20 into 5 to the power of x minus 25 is equal to 0. If you get a question like this, you have to remember that 5 to the power of 2x can be written as 5 to the power of x to the power of 2. Sorry, not like this. 5 to the power of 2x can be written as 5 to the power of x, 5 to the power of 2x times 5 to the power of 1, and that can be simplified as 5 to the power of x to the power of 2 times 5 to the power of 1, which is equal to, yeah, this is a simplified way. Okay, and now you can write this equation as 5 to the power of x to the power of 2 times 5 to the power of 1 minus 20 times 5 to the power of x minus 25 is equal to 0, and then you can sub in for y equal to 5 to the power of x. Okay, you can sub in for a new value, and then that will become y square times 5 minus 20y minus 25 is equal to 0, which is nothing but 5y square minus 20y minus 25 is equal to 0. And since 5 is common, you can simplify it as y square minus 4y minus 5 is equal to 0, and it's a quadratic equation which you can solve as y is equal to minus 1, y is equal to 5. Now you cannot stop here because y is the value which we introduced, so that you cannot stop here. You have to find the value of x because x is the value which is there in the function. So you say that 5 to the power of x is equal to minus 1, 5 to the power of x is equal to 5, and since it's a negative value, we can just neglect this and work on the other one. So 5 to the power of x is equal to 5 to the power of 1, so x is equal to 1. So this is how we find the value. Okay, now you can draw the exponential graph. So to draw any graph, you can use the range and the domain, and you can find the values using the calculator and then plot it on the graph. So for example, if you have y is equal to 2 to the power of x, or maybe they might give it as f of x is equal to 2 to the power of x. See, there's no need to worry when you see the function, because some of you might feel that functions are too difficult, but it is not. It's just the replacement of y. So if you think of like that, it is easy. So if you have a y here, you have f of x here, that is it. There's no other change. Okay, so if you have a function f of x is equal to 2 to the power of x, when you draw a graph, you might get something like this. Okay, so why this is called exponential function, and exponential function means the values will grow exponentially. That is why the graph is growing. And if you remember, the linear function will be like this, the quadratic will be like this, slow gradual increase, but exponential means it will fast increase. And if you okay, so this is the normal exponential function. So let me just talk about natural exponential function, which is e to the power of x. Okay, so till now what we have done is like any number to the power of x or x to the power of 3 or something. Natural exponents, exponential function is e is an irrational number. E is an irrational number which holds the value 2.7128 etc etc. No need to memorize this. And this is actually a bit we might think, what is this number? Okay, so this number has a unique property, and there is a direct link between the rate of change and the value of the function which it reflects, like some real world problems like carbon dating, exponential decay, population growth, etc. So that is why we'll have to work on this for a longer time. I mean for problem, not longer time, for many problems. So for E also, the rules of the indices holds good. For example, if you have e to the power of 2 over e to the power of 4, you can write it as e to the power of 2 minus 4, which is equal to e to the power of minus 2. E to the power of 0 is equal to 1. E to the power of minus 1 is equal to 1 by e. So all the rules of indices will work for this also. Now we move on to logarithms. So logarithms, when you say log of x, that is logarithms, and this is also there in page 21 of the formula and the tables book. And log also, you need to understand some of the rules. So log of xy is equal to log of x plus log of y. Log of x to the power of q is equal to q log x. Log of 1 is equal to 0. Then log of 1 over x is equal to minus log x. Okay, then another thing, log of a of x, which is equal to x. Okay, so there are some rules. It's not the full list, but something which I remembered, I just put it across. So there are some things which is there. It is there in page 21, so please keep it open. You need not memorize any of this, but you need to know how to apply it in the problem. For example, if you have something called log 3x plus 1 plus log 3 x minus 1 is equal to 1. So what you need to do is, like, you need to simplify this first. So which is like log 3 x plus 1 x minus 1 is equal to 1. That will be simplified to x square minus 1, which is equal to 1. And then since this is the base is 3, you can write x square minus 1 as 3 to the power of 1. So x square is equal to 4 and x is equal to plus or minus 2, and the answer will be x is equal to 2, as the log of the negative number is unidentified. Sorry. Now the exponents and the logarithms are very important topic, because this will come as long questions where they will explain about some exponential growth of a population or bacteria or carbon decay or things like that. Okay, so when it is growth, usually it will be a positive number, and when it is decay, it will be a negative number. For example, if there is a question which they talk about e to the power of t is equal to 50 e to the power of 0.02 t. Okay, since it is a positive number, positive, and since it is positive here, it is since it is positive here, it is growth. If it is the other one, it will be negative. Okay, and most of the times this is a function, so just don't get overwhelmed seeing this. Just in your mind, think of this as y is equal to 50 e to the power of, sorry, just in your mind think that y is equal to 50 e to the power of 0.02 t. So in that case, it is very easy. Okay, now they will ask you what is the initial value for this. Okay, so initial value always means t is equal to 0. So what you have to do is, like, you have to put the value. This can be any function. Okay, for example, it can be population growth or exponential growth of a bacteria colony, or anything like that. So when t is equal to 0, what you have to do is, like, you have to sub in the value of 0 instead of t, okay, here, and that is equal to 50 e to the power of 0, and e to the power of 0 is equal to 1, so the answer will be 50. Okay, then they will say, okay, after 5 hours, or maybe 5 hours. Okay, so after 5 hours, a of t will be equal to 50 times e to the power of 0.02 into 5, and that is equal to 50 e to the power of 0.1, that is equal to 55. So you put this into the calculator and you will get the value. Okay, and then they can say that at what time a of t will be, they will not say a of t, at what time this bacteria growth will cross 1000. Okay, so you have to read the question and understand that, okay, it is the value of a of t they are mentioning. So then what you do is, like, you write 1000 for that, and then 50 e to the power of 0.02 t. Okay, and then you simplify this. So here the question is to find the value of t. So you simplify it by 1000 over 50 is equal to e to the power of 0.02 t. So 1000 over 50 will be 20 is equal to e to the power of 0.02 t. Now once you have only e on one side, what you can do is you can put ln. Okay, sorry, you can take ln, okay, log. So log with respect to e. So you take ln. So ln 20 is equal to ln e 0.02 t. Okay, and ln and e will get cancelled each other. So you can write ln 20 is equal to 0.02 t, and t is equal to ln 20 divided by 0.02. And if you put it into the calculator, you will get the value, okay, maybe 149.79 hours, or whatever the time is denoted by the question, you will get this.